square. That is nothing but 6 square upon what? 2 square. That is 36 upon 4. After further simplification, what I get? 9 upon 1. So I got my answer. What is the answer? Area of triangle ACX is to area of triangle BDX is 9:1. Or in other words, I can say that triangle ACX is to triangle BDX is equal to 9:1. And the sum gets over. Now when you see the next sum, see what is given to you. It's a total calculative sum. See the figure very carefully. In the adjoining figure, PA is a tangent. In this sum, when you see the tangent very carefully, with the help of the tangent, one chord is drawn, and on that chord there is one triangle. So we get a intuition of alternate segment theorem. Yes, we'll be using in this sum. What else? To a circle with center O, so center of the circle is what? O. Calculate X and Y. In this sum, we have to find the value of X and we have to find the value of what? Y. Let's start solving the sum. See how do I proceed further for this sum. First of all, reflex of angle BOC is what? 360 minus 144. That is nothing, 216 degree. So 216 is the reflex of angle BOC. From here what I get? I can find now angle BAC is half of reflex angle BOC. Why? Because central angle is always twice the angle at the circumference. Therefore, what do we get the value? What I get? Angle BAC is half of 216. That is half of 216 is 108 degrees. So what is 108 degrees? Is the measurement of angle BAC. Now see the triangle. Which triangle? ABC very carefully. Sum of all the three angles is what? 180. Therefore, what do we get in this triangle? 3x plus angle BAC plus 5x is equal to what? 180. Once again I repeat, sum of all the angles in a triangle is what? 180. So what I get? 8x plus 108 is equal to what? 180. 8x is equal to what? 72. And x is 72 upon 8, that is nothing but what? 9 degrees. So I got the first answer, x is equal to what? 9 degree. Now I have to find y. Now with the help of this, see, can I say angle CAP is what? 3x? See the figure very carefully. Can I say angle CAP is equal to 3x? Yes, why? Alternate segment theorem. Therefore, what I come to a conclusion? That angle CAP is 3 into 9, that is what? 27 degrees. So I got a measurement angle CAP. Now see the triangle CAP very carefully. In this triangle you got y. I want to find this y. Can I get 5x? Yes, 5 into x is what? 5 into 9. That is what? 9 5 is 45 degrees. This 45 is the measurement of angle ACB. Now this is the exterior angle of triangle ACP. So what do I get? What I get a conclusion that 45 degree is equal to angle CAP plus y. That is 45 is equal to 27 plus what? Y. 45 minus 27 degree is nothing but what? Y. That is y is equal to 45 minus 27, that is 18 degrees. So what I get finally the answer of y? That is what? 18 degrees. What I get x is what? 9 degrees and y is what? 18 degree. And the sum get over. Now let's see this chapter from board point of view. I want to say from ICA's examination point of view. Has to be one of the good chapter, one of the important chapter basically, because it carries some good weightage. 4 marks, 8 marks depending upon that. It can be either in section A or section B. There's nothing fixed. There can be 1 question or 2 questions also from the single chapter. From the past few years, it can be seen that there are 2 questions asked on this one chapter. Yes, 2 questions from this single chapter. If I take 3 and 4, 7 marks, 4 and 4, 8 marks. So 8 marks itself from one chapter out of 30 plus chapters. So it means a lot. In short, start doing more practice. Take more interest in this chapter. Okay, let's pick up some board exams sums from this chapter. I'm starting with a sum which has come in the year 2005. See the sum very carefully, what is given to you. We read the sum first of all. In the figure given to you, PM is a tangent. Okay, no problem. What else? To the circle, and PA is equal to AM. Yes, this is a very important condition given to you. I read once again, PA is equal to what? AM. 2 sides of a triangle. Which triangle? Triangle PAM are given to you what? Equal. Definitely we are going to use isosceles triangle property over here. Okay. What are you going to prove now? You are going to prove that triangle PMB, the bigger one, PMB is an isosceles triangle. Okay. What is the second thing? You are going to prove that PA into PB is equal to nothing but MB square. Very, very interesting sum. This year must be definitely a good year because such question comes in a good year. Very important sum. Let's try to make it as simple as possible. See, first of all, what I'm doing, I'm picking up a triangle PAM. In this triangle, what do I have? I have angle APM is equal to what? Angle AMP. You know what's the reason? Base angles of isosceles triangle are always equal. Okay, what else? And by alternate segment theorem, now see the figure very carefully. What I get? I get angle AMB, see the figure very carefully, is equal to angle AMP. What's the reason once again? Alternate segment theorem. Okay, so you got 2 angles are equal. Therefore, the triangle, which triangle I'm talking about? Triangle PMB becomes what? An isosceles triangle. How? Because the 2 angles are equal. Which 2 angles are equal? Angle APM is equal to what? Angle ABM. From the above statements, we get these angles are what? Equal. Therefore, the base angles are equal. And if the base angles are equal, that triangle becomes what? An isosceles triangle. So from here, what do you get? From the property of isosceles triangle, what I get? I get PM is equal to what? MB. Remember this, PM is equal to what? MB. It's a very important statement. Will be useful in the next part of the sum. I repeat once again, PM is equal to what? MB. Okay. Now see the second part of the same sum. What is asked? Prove that PA into PB is equal to MB square. By using rectangular property of circle, what I get? I get PM square is equal to PA into what? PB. But already what you have proved? You have proved that PM is equal to what? MB. Yes, you have proved that. So instead of writing PM, can write MB? Yes, you can write that. Therefore, what I get? I get MB square is equal to PA into PB. And the sum get over. That's what you're going to prove.